Okay, so we are going to take a look at Unit 4. We've been working with right triangles, and in the last week lesson, we learned a little explore about this table. And we created a bunch of triangles with these various degrees, and we discovered that the ratio between the adjacent and the hypotenuse always works out to be these numbers with these angles. We learned the ratio between the opposite and the hypotenuse will work out to be these ratios, and the opposite leg and divided by the adjacent leg will work out to be these ratios. And we're starting with multiples of 10 because this table gives us a good way to see these relationships and you can see the patterns. For example, in class we talked about how the 10-degree angle and the 80-degree angle are complementary. So 90, if we have a 90-degree angle, a right angle, the other two angles have to add up to 90. So if you look at the 10-degree angle and you look at the 80-degree angle, you'll see that the ratios between the adjacent and hypotenuse, opposite and hypotenuse, are reversed. So if you look at the 10-degree, it's 0 and 985 thousandths, 0.985. But down here for the 80-degree angle, that is the opposite divided by hypotenuse. And that would be 0.985, 985 thousandths. And it works the same thing for the opposite and the adjacent. So if we do the 10-degree, 0.174, 174 thousandths. 80 degrees, the adjacent divided by hypotenuse is 174 thousandths. So there's a relationship here going on between these, and that is because the adjacent and the opposite can be either leg, depending on the angle that we're looking at. So we're going to take a look at an example. So these were a few that we did in class. So I'm going to redo them on the video so you can kind of watch and take it in a little because it's a lot. It's a lot to learn. Okay, so we have this triangle here. It is a right triangle ABC, and they're giving us the length of the hypotenuse. So the hypotenuse is always going to be the length, the side across from the 90-degree angle. It's always the one that is going to be the opposite of the 90-degree angle. It is also the longest side of the triangle. Now, they're giving us the 20-degree angle. So I'm going to switch colors here, and I'm going to highlight this in orange. Okay, so we're looking at this angle right here. Well, in order to figure out which of these formulas we're going to use, we have to identify which is the adjacent and which is the opposite. I always start with the adjacent because it is the one that is connected to the angle. So if you see here, the orange arc is my 20-degree angle, and that leg that's attached to it is the adjacent. Okay, so this one is adjacent. All right, and then the one that is opposite, kind of like the opposite of the right angle, is the hypotenuse. The one that is opposite from the 20-degree angle, this guy over here on the opposite side, that is the one that is opposite. Okay, so now we've identified our two legs. So now we know that if we divide adjacent by hypotenuse for a 20-degree angle, we will get this quotient, 0.940 or 94 hundredths. Okay, so I can use this table chart here to help me identify the length of AC and the length of AB. Okay, so I'm going to switch to paper for this next part. I'm going to make it nice and big, and what I've done is I've just taken the division ratio with the answer, the quotient, from the table and put it on this notebook paper. So that way I could work out the math a little bit easier. I've labeled my adjacent and my opposite and hypotenuse. So now all I have to do is fill in what I know and solve the equation. Okay, it's just a finding the missing number situation, right? Okay, so I don't know the adjacent, but I do know the hypotenuse, right? So I'm just going to write x, because that's what we don't know. Okay, I'm just going to call this x. We don't know it. X divided by 8.5 is going to give me 0.940. Okay, now I can just do my math. This is an equation. I'm going to think of this as something divided by 8.5 will give me 940 thousandths or 94 hundredths. Okay, so I can use my inverse operation here. Instead of divide, I can just multiply 8.5 times 0.94. I'm just using the inverse operation, and I'm going to get an answer. So I'm going to use my calculator, which is totally fine. 8.5 times 0.940. Okay, and I get 7.99. So that is the length of the AC. So I can use 7.99, which is fine, or I can say this would be about 8. And we're going to talk a little bit about our estimating in our lesson the next class. So just know that really we got 7 and 99 hundredths, but we're going to say this is about 8. So I'm going to put 8 down here as my adjacent. This is my x. Now, the question doesn't really ask us to find the opposite, but we're going to go for it. We know now that this is AC, or the adjacent. Let's see what the opposite is. We're going to call this y, just different variable. And I'm going to use this formula because this is the opposite, and I know the hypotenuse, so I'm going to figure it out. Now, I do already know the adjacent, so I could use this formula as well, but we're going to do that one last just so I can show you how we can use it to check. Okay, so we have opposite. We don't know what it is, so I'm just going to call it y, since I don't know what it is, and I'm going to divide it by the hypotenuse, and that is going to equal 0.342, 342 thousandths. Same strategy as above. Okay, I'm going to multiply these together, and I'm going to get an answer. So let's see what that is. 8.5 times 0.342. And I got this 2 and 907 thousandths. I'm going to write the actual answer, but I could say that this is about, now I could give this a few different, depending on how we round, I could say this is about 2.9. Or if I wanted to go to the nearest whole number, I could say 3, but we got to be careful because the further away we get from the actual answer, things start to get a little messy. Now, I'm going to show you how we can check. So if I plug 2.907 in for y and divide, I should get 0.342. And it might not be exact because as we learned in the table Explorer last class is that this is like a mean or an average of the ratio because it doesn't always work out 100% perfectly. So let's go ahead and plug in what we got for y, 2.907, and I'm going to divide that by the hypotenuse. This is my opposite, 8.5, and look what that gave me. Perfect. Okay, so now I know the length of AB. This is AB. So I can say 2.9 or I can say 3. I mean, again, you can use your own best judgment of what you would like. If it's a multiple choice question, sometimes you might see 2.9, sometimes you might see 3. Okay, these are very comparable numbers. Okay, so watch how we can check. Now, we just figured out, using the hypotenuse, we figured out the adjacent and we figured out the opposite. So now we have all 3 sides of my triangle, even though I was only given 1. Now watch how we can check. Opposite divided by adjacent. Let's take the opposite and divide it by the adjacent. Now I'm going to use the actual answers, right? Because I want to get as close to this answer as possible. So I don't want to use the estimations. Okay, opposite is 2.907. And if I divide that by the adjacent, which I figured out is 7 and 99 hundredths, 7.99, I should get this if I did my math correct. So let's see what happens. Okay, 2.907 divided by 7.99. Look what we got. 0. Now we got a lot of decimals, but just look at the first couple. 0.364. 0.3638, but that 8 will round my 3 thousandths up to 4 thousandths, and that would be accurate. Okay? Now watch what happens if I put 8 divided by 3. Let's round to the nearest whole, and I'm going to show you how it will change the ratio a little bit, but it's going to be close, but not quite exact. Okay, so watch. I'm going to change this to 3, and I'm going to divide it by 8. And notice our answer's off ever so slightly. So that's why when you're working with the ratios, you want to try to use the number as close to the actual. Now, obviously, if it's a run one decimal that has several decimal places, I always say the first 3 decimal places, tenths, hundredths, thousandths, and you're safe. You know, if you use 3 decimal places, that's usually pretty good. Okay, now watch how cool this is. In the last unit, we realized or reviewed from Math 8 that we know when we're dealing with a right triangle that a squared plus b squared is equal to c squared. Okay, this is something that we know is true about right triangles. Well, now that I have all 3 measurements and I used my ratios for my right angle for the 20 degrees, and I use this information, now I can use the Pythagorean theorem to take it one step further and just double check to make sure I have my answer correct, because 8 squared plus 3 squared should equal my BC squared. Okay, so again, I'm going to go with the numbers I'm going to go with the closest possible number. Instead of using 8, I'm going to use 7.99 or 70 and 99 hundredths squared, plus I'm going to just use 2.9 for this one. And that is going to equal 8.5 squared if I did my math correctly, right? All right, so let's pull out the calculator. And I'm using my standard calculator here. I know that the square is just 7.99 times 7.99. So rather than pull out my scientific calculator, I'm just going to multiply them together. Okay, now again, do you see this? 63.84 plus 2.9 times 2.9. And if I did this correctly, these two added together should equal 8.5 times 8.5 times 8.5, which is 72.25. So let's see if it works. All right, 63 and 84 hundredths plus 8 and 41 hundredths, and look at what I got. It checks out. So the Pythagorean theorem worked as well as our ratios. We were able to calculate everything. And guess what? We know that this is 90 degrees, and we also know what this is. Remember, a triangle is 180 degrees. I've already got half of that 180 right here. So 20 plus something has to equal 90, right? 20 plus 80. And again, if you go back to that table that we just talked about, these are complementary. And we're going to talk about these in the next example. All right, so here we go. We just figured this out. We're pros, and all we did was use the information from the table. Now, I'm going to skip ahead a couple questions. Now, we did a lot of these in class, but I'm going to go to lesson 6, and we're going to take a look at this one. So in lesson 6, they're giving us 2 angles, okay? We have 2 angles here, and we're looking for the hypotenuse. So now we're going to be missing the hypotenuse. So we're going to use the information on the table just like we did. However, for this one we have to be really careful, because depending on which angle we're looking at, the adjacent and the opposite are going to be different. So if I'm looking at the 40-degree angle, this is the adjacent, and this is the opposite. See that? But if I'm looking at the 50-degree angle, it's reversed. The 3 is the adjacent, and then the other one that we don't know is the opposite. See that? So we have to be really careful when we're using our ratios that we're looking at the right legs. You're looking for the one that is on the angle, attached to the angle, that would be adjacent, and the one that's opposite. That is probably the trickiest part of all of this. All right, so here we go. I'm going to pull out my document camera, and I have the same triangle. The hypotenuse is the missing number. That's the one we're trying to figure out. It is always across from the right angle, okay? Always. If this is something you can count on. The hypotenuse is always the opposite of the right angle, and it's the longest side. And we're going to use that in just a second to back up what mistakes that people often make. All right, well, here's the tricky part. We don't know the hypotenuse to either of any of these. The last one we knew the hypotenuse. It was a little easier, right? Because they gave us the hypotenuse, which is um, the denominator of both of our fractions for our ratio. But for this one, we don't have the bottom. We only have the top. So we have to start with our 50-degree and use the adjacent formula, or we start with our 40-degree and we use the opposite. I have it set up to do both, but I'm going to do the 40 first. So I'm looking at my 40, so this is the adjacent. I don't know it, so I have to use the opposite. So I'm going to skip this formula. I'm going to use this one. Okay, 3 divided by z, because z is my hypotenuse. I don't know what it is. It's going to be equal to 0.643. Okay. Well, this is a tricky one because our missing number is our denominator. So while a lot of people think that we need to multiply these two together to get the answer, we actually need to divide. And let me show you what happens if we multiply. So if I do 3 times 0.643, watch what happens. 3 times 0.643, 643 thousandths. Look what I get. My answer is 1.929. How can that be the hypotenuse, right? Because 1.9, that's like 2, right? How can the hypotenuse be 2 when one of the legs is 3? It doesn't make sense. So right away you can kind of be like, ding, 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 I did something wrong here, because the hypotenuse is the longest side of the triangle, so it has to be greater than 3. So we're going to divide these two. 3 divided by 0.643. Okay, 3 divided by 0.643. And I get the answer 4.6656. And you're like, Miss Bree, that's a lot of numbers. That's okay. I'm going to leave it there because remember we talked about the closer we can get to the actual real answer, the better it is for our answers. Okay, so I think the hypotenuse is 4.6656. That's what we think. So let's see if we can use the hypotenuse to see if we can figure out this formula. Or we can use the 3 right here and see if we can figure out the adjacent using this formula. This is wonderful because we can choose either one. I'm going to go with the 3, which is the opposite of the 40-degree angle, and I'm going to use this formula. Okay, so I'm going to call, let's see, opposite is 3. Let's call this one x. Okay, this is my adjacent, so I'm just going to call it x. All right, so 3 divided by x, which I don't know. I don't know the adjacent. Okay, so I had to think about that for just a second. I don't know the adjacent. Okay, so here we go. 0.839. All right, let's see if this works. Just like this equation, I need to divide these two because I'm missing my denominator. So 3 divided by 3, I'm running out of paper here, divided by 0.839. Let's see what that gives us. Okay, 3 divided by 0.839. Okay, I got 3.57568. These are a lot of numbers. I'm going to try to take it as far as I can go. I'm going to do 3.576. I did 3 place values here. I should probably do 3 here, but that's okay. We're going to stick with this. So now this line segment, JG or GJ, I can assume that that one is about 3.6. Okay, so now I know my adjacent. So I'm going to fill it in. 3.576. We've got this. They gave this to us. And our hypotenuse, we're thinking, is 4 point, we're going to say 665.6. We're going to use all four of those. All right, here we go. Moment of truth. Moment of truth. If I did my math correctly, okay, and these are reasonable. It's reasonable to guess or to think that this is 3 and this is 3, about 3.5. Because look at the angles. Remember what we learned about a square? These angles, if they're both 45, then we're working with a square. This is half of a rectangle, but it's really close to a square because this is 40 and this is 50. So they're only 5 degrees off. So it would make sense that one leg would be just a little bit bigger than the other leg. And 4.5, 4.6, that's a good estimate for a hypotenuse. All right, so let's fill in what we know. Now we know the adjacent. That's 3.576. And I need to divide that by the hypotenuse, which we just figured out is 4.6656. I'm going to use all of the numbers just because I want to get as close to this as possible. If I divide these two, I should get 0.766. That's the ratio between the adjacent and the hypotenuse. Adjacent by hypotenuse on a right triangle. So let's see what we get. 3.576 divided by the hypotenuse, 4.6656. And look what we got, 0.664609, etc. But yes, we got 0.766. So I know this is correct. I know this is correct, and I was given this, okay? Now, let's look at it from a different perspective. We already know the answers now, but let's use the 50-degree angle measurement. Okay, so I'm going to come over here and I'm just going to act like I don't know what these are. And I'm going to start with the 3, which is the adjacent. Okay, so this is my formula. I'm starting with this one as opposed to this one. This was the one I started with for my 40. Now I'm going to start with this formula for the 50. Now remember, it's going to be the opposite. These two are like flip-flopped because 40 plus 50 is 90. Okay, so whichever one you're using, the adjacent, the opposite is going to be reversed. Okay, so I'm going to come over here and I'm going to use my 3. I don't know what my hypotenuse is. I mean, I do, but I don't. I'm going to start from scratch. I know that 3 divided by z is going to equal 0 and 643 thousandths. This is proven. I know this is going to be true. So if I just divide 3 divided by, because remember I'm missing my bottom number, the denominator. When I'm missing the bottom number denominator, I actually need to divide these two. 3 divided by 0.643. Let's see what we get. Okay, 3 divided by 0.643. 4.66. Oh gosh, look, that's exactly what I got. So now I know my hypotenuse is correct. I did it twice. I used the different angle and I still got 4.66. And I'm just going to call it 4.66 at this point. Okay? So now I know that's my hypotenuse. That's my z. Z is equal to. All right, let's see if it works for the opposite and the hypotenuse. I think the opposite is 3.576, right? The one that's opposite of the 50. So let's just go ahead and divide these two and see if we get 0.766. So here's the opposite of the 50, 3.576. And I'm going to divide that by what I just got, the hypotenuse, but I'm going to use 4.6656. Remember, the more decimal places, the better. If I did my math correctly, which I'm pretty sure I did because all of this checks out, I should get 0.766. That's the ratio between the opposite and the hypotenuse. All right, so let's see. 3.576 divided by 4.6656. Bam, look, 0.766. Obviously there's more, but that's okay. It checked out. See that? Check. All right, now, moment of truth. If I take my opposite and my adjacent, bam, and divide them, I should get 1.192. So let's take the opposite, 3.576, and let's divide it by the adjacent. And let's just double check to make sure we get 1.192. Okay, 3.576 divided by 3, 1.192. So it checks out. I know that these answers are correct. Now, watch the coolest thing ever. Remember that? A squared plus B squared equals C squared, right? Remember that. 3 squared plus this squared, and I'm going to use 3.576 even though it's a big number, because remember, the closer I am to the actual answer, the closer I will get to this. And this should equal 4.6656 squared. Now, in reality, we could say that this is just about 4.7. This is just about 3.6. Now, when we get into our lessons coming up, we're going to talk about how the bigger the triangle, the more it's important to keep to as close to the actual answer as possible. But for our purposes, you can estimate. But I'm using the actual numbers just to prove a point. Okay, we know 3 squared is 9, not 6. It's 3 times 3, not 3 times 2. Okay, 3.576 times 3.576. I could use the square root button, or the square button, but I'm just using this. Okay, guys, look, way too many decimal places, so I'm going to stick with 12.788. I round it to the nearest thousandths. All right, and that is going to equal 4.6656 times 4.6656. And again, I'm just going to take it to 3 decimal places. 768. So that, see the 8, that helps with my 7, rounding it up to the next thousandth. Okay, moment of truth. If I add these two together, I should get this answer, or at least close to it. 9 plus 12 and 788 thousandths. And look what I got. Pretty close, okay? Now, why is this off a little? That's because we rounded. We rounded a number that had a lot of decimal places. So I'm going to show you how rounding really does impact the answer, because watch, if I were to keep this 9, and let's say I rounded this 3.5 squared, what if I rounded this to 13, right? Because that's reasonable. 12.788 is about 13. Okay, watch what happens. 9 plus 13 is equal to 22. And this is technically 22. So you see how rounding your answers, your numbers are going to be off just ever so slightly. But see how we use the Pythagorean theorem to check. Okay, last but not least, in class we learned about the cool calculator button. So I'm going to delete all of these out, right? Because I want you guys to be able to see it, especially if you weren't here. Okay, so what we did in class is we learned about the buttons cosine, sine, tangent, cosine, sine, tangent. There's 3 buttons on your calculator that you've probably recognized, you've probably seen, and you've probably wondered what they mean. So they're asking us to use our calculator just to type in cosine 50. So I'm going to take the cosine button and I'm just going to put 50 in here. And I have this number here, Control C, and I'm just pasting it in here. Okay, now I'm going to do sine 50. And I'm going to paste. And then I'm going to do tangent, tan 50. And it's short for tangent. We're going to talk more about these vocabulary words in the next class. Okay, so I'm just going to do the 50. Now look, do you see these answers? All right, watch how cool this is. I'm going to open up my document camera and I'm going to kind of, okay, for a 50-degree angle, adjacent divided by hypotenuse is 0.643. And look what we got, 0.643. You see how it's a repeat decimal? The calculator button is giving us that this division right here, adjacent divided by hypotenuse, they're giving us the full number in the calculator. So this is the cosine. Okay? Now, let's look at the hypotenuse. Sine 50, 0.766, and that's exactly what we have here, 0.766. So this is the sine, opposite divided by hypotenuse. And then let's look at the last one. the tangent of 50, which is opposite divided by adjacent, is 1.192, which is technically what we have here. So we call this the tangent. Now, let's look at the 40. Okay, now I'm going to just delete these out so it doesn't get confusing, because when you get all these decimals in here, it does look a little confusing. I'm going to clear all. Okay, now cosine 40. Cosine 40, okay, sine 40, and tangent 40. Okay, now watch how cool this is. Let's go back to the document camera and let's look at our adjacent divided by hypotenuse, 0.766. Bam, it's the cosine. See that? And then of opposite, 0.643. 0.643. This is the sine. And then the last one, 0.839. 0.839. This is the tangent. Now, these buttons basically provide a shortcut for us so that we don't have to do adjacent divided by hypotenuse. We know that if we hit the cosine for 40-degree angle, it's going to give us this number. If we hit sine for the 40-degree angle, it's going to give us this number. And if we hit tangent for the 40-degree angle, it's going to give us this ratio. And if we do cosine 50, we're going to get the adjacent divided by hypotenuse ratio. If we do sine 50, we're going to get the opposite divided by hypotenuse ratio. And if we do tangent 50, we're going to get the opposite divided by adjacent. This is taking the place of the table. Taking the place of the table. Okay? Now, why is this important? Okay, so I'm going to show you one last really cool thing. Why is this important? Well, in our math that we did a lot of that estimating. Remember that estimating we did? Okay, so if we use the calculator button, we will get a little bit more of an accurate measurement. So watch how I'm going to do this. Let me make my screen just a little bit bigger here. All right, I'm going to use the Desmos calculator, okay? And I know that I have let's start with the 40-degree angle, right? I have a 40-degree angle, and I know I'm looking for the hypotenuse, right? I know I'm looking for the hypotenuse. So remember when we did this first one, we started with 40, and we used this equation. 3 divided by something equals 0.643. So instead, all we have to do is take 3 and multiply it. Actually, here, I'm going to make this a little bit smaller. Hold on. Okay, so I can split screen here. Okay, all I have to do is take 3 and divide it by the button sine of 40. Okay, watch. 3 divided by sine of 40. And it's going to give us that 4.6656. So now I know that that's the measurement of the hypotenuse. Okay, now watch. Let's try another one. Remember, we figured out the hypotenuse, right? So we went down here and then we did this. Opposite divided by adjacent. 3 divided by adjacent is going to equal 0.839. So we realize that we have to divide these two. 3 divided by the tangent of 40. All right, let's see what happens. 3 divided by the tangent of 40. Look, 3.57, and that's what we got. So now we know our hypotenuse and our other leg. So we just figured out all 3 without having to write the equations, okay? Now again, writing out the equations is super important. It's definitely good practice, but these calculator buttons help us to save a little step. All right, let's try it for the 50. Okay, so now we're going to use the 50-degree angle. Remember, we started with this first one. Adjacent divided by hypotenuse. 3 divided by what we don't know is going to equal 0.643. So we realize that because the denominator is missing, we actually have to divide. 3 divided by the cosine of 50. That's all I need. I don't even need to know this decimal. I just need to know that it's, okay, adjacent divided by hypotenuse. That means I'm using cosine. So 3 divided by the cosine of 50. Look, 4.66. That's what we got. All right, let's try the next one. Let's do the opposite divided by the hypotenuse. Let's try opposite divided by the hypotenuse, okay? Let's see. We know both of those, so we might not even use that one. Let's try the third one. Opposite divided by adjacent. Okay, so we don't know the opposite, but we do know the adjacent. So this is an example of x divided by 3 equals 1.92. So we can multiply here 3 times 1.92, the tangent of 50. All right, let's see what happens. 3 times the tangent of 50. 3.576. See that? And that's what we got. So now we know all three of the numbers. Now, even better is the a squared plus b squared equals c squared. Let's use the actual numbers. Let's use these larger numbers, right? Watch how cool this is. Okay, 3 squared plus the other leg, which is this right here, 3.57, yada, yada, yada. I'm just going to do a control C squared equals, do you see this? 21.782. That's what we got. But let's see if it's 4.6656. All right, so it should be the square root of that number. 4.6656. Pretty close. 4.66. We could stop there. Okay? All right, so this is what we did in class, and we will continue to practice this. We actually only got up through the reference table chart, so we're going to be adding these to our reference table for our next class. And we did one more practice, but again, we'll have time in class to practice this. Please watch this video, and again, if you're having a little trouble with this, it's okay. It's brand new stuff. Brand new stuff.